For the next principal component analysis Python code, we will be focusing on iris dataset. So let me first explain what this dataset is, and then we will move on to the Python code where we'll apply the principal component analysis on the iris dataset. Iris dataset is one of the most popular dataset that is used in the domain of machine learning. It has been created by University at California, Irvine, and this is stored in UCI's machine learning repository. Essentially, it is a data set about a flower, iris, which has three different types of subcategories or different types of iris flowers. Okay, and each of those are essentially setosa, versicolor, and virginica. These are the three different types of iris flowers that you have, and in this data set essentially comprise of three classes of 50 instances of this setosa, versicolor, and virginica class of flowers. Now, with respect to each of these classes, what typically are the features in this data set are the petal and sepal dimension. So, when we are talking about the petal dimension, the two features that are stored in this data set is the petal width and the petal length. And similarly, for each of the flower category, you have sepal width and sepal length are the additional two features that is there in the overall data set. So, essentially, for each flower, people have measured this petal length, petal width, sepal length, and sepal width, and that is essentially stored in the data set. And we have this measurement for 150 different instances of the iris flower belonging to three different categories, which are setosa, versicolor, and virginica. So let's see how can we apply principal component analysis on iris dataset. Now, as I have discussed, the iris dataset essentially has three different classes. Iris setosa, which is represented by class 0 in this overall data set. Iris versicolor, which is represented by class 1 in this overall data set. And then you have iris virginica, which is represented as class 2. And again, repeating that we also have four features, which are sepal length, sepal width, petal length, and petal width. Now, since we have four dimensions, what we want to do is we want to apply a principal component analysis and reduce the number of features or number of dimensions of this data to maybe 2 or 3 features. And why we might want to do that? Because if we do 2 feature dimensions or 3-dimensional feature, then hopefully we will be able to visualize this data set, and we will have some visual representation of this data set. And from that visual representation, we can see how hard or how easy will it be to classify this, use a classifier or algorithms like that to classify in this data set itself, right? So we can do some visual inspection, and that visual inspection can give us insight on whether we can be easily classifying among different classes of the iris flowers that are there. Okay, so let's see how we can apply principal component analysis on one of the most favorite data sets in machine learning, which is the iris data set. Okay, so what we are doing here is, again, iris data set is available on sklearn library. Okay, so again, similar, we are calling numpy, and then we are importing this data set from the sklearn. Okay, and then first thing is we are looking into the attributes of this data set as in a table form. So for that, we have used essentially pandas. Pandas as a library, we have imported that in the environment, and then we are basically displaying the information that we have for the iris data set in a tabular format. So you can see the table that is listed here. Now, this table that you see here has essentially entries of 0 to 149. So it's essentially 150 data points that we have. That's the number of rows in this overall data that you have. And as you can see, there are 5 different columns. The first 4 columns are essentially the 4 features that we are interested in representing, which are like sepal length, sepal width, and petal length and petal width. And then the fifth column essentially specifies the class or the type of iris, right? 0 belong, again you can go here and you can see that 0 is setosa, 1 is versicolor, and 2. So that class information, the type of flower, is essentially represented by the fifth column that you have in this data set right here. Okay. So as you can see, there are 150 instances of the data and they have 4 features each. Okay. So let's first of all calculate and do normalization and calculate the variance captured by each of the individual features that we have in the data set. So that's what we have done in this block of code, where we have basically first performed the normalization aspect of it, and from the normalization aspect of it we have tried to compute the variance in this overall data set. Okay. And then finally we have focused on computing the percentage of variance. So if you look into this, right, the percentage of the variance captured by different features are given by this array. Okay. So there are, the first feature is 19% capturing the 19% of the variance. The second feature is capturing this 11% of the variance. The third feature is capturing the 32% of the variance, and the last and the fourth feature is capturing the 36.5% of the variance that is out there. Okay. So again, there are 4 features, and as I mentioned in the beginning, 4 features, it will be, if you have 4 dimensions, it will be hard for us to visualize. So maybe we want to do dimensionality reduction and reduce the number of features to maybe 3 and 2, and that's where we will be using the PCA to reduce the dimensionality and visualize that data in 2 or 3 dimensions. Okay. So in order to apply the principal component analysis on this data set, first thing that we will do is we will basically use a sklearn library, and we will import the PCA functions from that. Okay. And then in the block of code we are basically fitting the PCA to the X, which is the data that we have. X is the data which is storing the 4 features of the iris data set that we have. Okay. So from there, now what we will do is move on, and we will essentially run this, and we will fit this PCA model, and then from there, as discussed previously, we will get the ordered singular values. So we will order the singular values according to the importance that is there, and as you can see, once we are doing ordering, the singular values that we get out of and doing the principal component analysis are 25.09, 6.01, 3.41, and 1.84, right? So again, the information captured by the different principal axes after doing the PCA, 4-dimensional that it gets transformed, that different principal axes are capturing different amount of information. Turns out the first dimension after doing the principal component analysis captures the 68.93%. Okay. The second dimension captures 16.51%, and the third dimension captures 9.38%, and the fourth dimension captures 5.18% of the overall variance that we have. So what has happened is the original variance that we had got redistributed to different principal axes, right? So the original distribution in the first, second, third, and fourth feature was 19.15%, 11.94%, 32.4%, 36.5%. When we applied and transformed that data into 4-dimensional PCA, the first axis of the PCA or the singular values was able to capture the 68.93% of the variance. The second axis is capturing the 16.51% of the variance. The third axis is capturing 9.38% of the variance, and the fourth axis after transformation is capturing the 5.18%. So that is still the data is in the 4 dimension, right? And what we want to do is we want to use this variation information, and we want to reduce or reduce the dimensionality by throwing away one of the dimensions that is going to be there. So the best way to throw away is probably begin with the dimension which has the lowest, which is capturing the lowest variance. In that case, in the case that you see here, the lowest variance is going to be captured. If I have to convert this data into 2-dimensional data, then the lowest variance are captured by the third and the fourth dimension, which is 9.38 and 5.18.